In today's class, we'll be discussing about the next elements of your data preprocessing. That is about again a revision of your data cleaning. We'll be discussing about data integration and transformation methods, and later on we'll discuss about data reduction, data discretization, which is again an important point of your data transformation, and concept hierarchy generation. After that, we'll be having an overview of all this chapter again. So moving ahead with the concepts, what we have already discussed. So why to preprocess your data? Okay. So in real world, data is not pure. That is, data is a bit dirty. Dirty means which consists of missing values, some noise, some dispensaries in your data, some unwanted symbols, which can be due to a number of reasons, right? So with respect to this data preprocessing, so in real world we have data which is incomplete. Incomplete means here you can see the example, like occupation is taken as empty. That is, somebody who is operating the data has missed this value. So while doing analysis, we may get some problem. This is what we call as incomplete data, right? And next, data will be having some noise. For example, if I say example of salary, salary will never be negative, but here you can see the salary is -10. So this is something noise. The minus symbol here is something noise which is deviating my analysis. So if you are having such type of data, then we need to perform data preprocessing. Whenever you are having some missing values or incomplete values, whenever you are having some noise in your data, and whenever data is inconsistent, that is, which contains discrepancies in codes or names. For example, here you can see age is equal to 42, birthday is equal to 03/07/1997. So it should need to match with the number of date of birth. Then only it will be correct. For example, if your age is 25, according to your whatever your understanding, but if your birthday is something like 1990 or 1980s, then that might not be a proper deviation, right? There will be some problem with analysis. In the same manner, for example, sometimes whenever they are asking to give rating in 1, 2, 3, and if you are giving rating as ABC, then again that will be a inconsistent form of data. That is, because you are creating some data and somebody is understanding, who is trying to understand your data might not be aware of what actually is this A, B, or C, because they were expecting you to give data with respect to numerical values 1, 2, or 3. So this is how there will be some problems in your data. So to remove the problems in your data, we actually go for data preprocessing. Okay. So I hope this slide is clear to all. Yeah. Why data is dirty, or why data is not properly arranged? Why? What are the actions you need to take, and why do we get such a problem? That is, incomplete data may come from uh, NA values when corrected. That is, some missing values, or they'll be giving as I already said in the classroom, you will be giving as NA. Different consideration between the time when the data was corrected and when it was analyzed. For example, a data was corrected 5 years ago, and suppose if I take the employee salary of 5 years ago, there may be a lot of rise in his salary due to hikes or something. So the employee data, whatever you're collecting or analyzing, need to be a live data, that is taken in the same year. Suppose if you are trying to analyze some 5 or 6 years of data of some employees, then in this span of 5 years, there will be a lot of changes that need to be updated. If that is not updated, then analysis might not be correct. Okay. And apart from that, there will be some human or software problems through which there will be a incomplete data form. And next, you have a noisy data which comes from the process of data. That is, noise happens due to the improper collection of your data, entry values problem, or data transmission. While transmission from Excel to other forms or database, you may get some errors, right? That is one way of one problem of your noisy data. Next one is inconsistent form of your data. That is, data will be inconsistent due to different sources. For example, if you are working for an organization called as Amazon, Amazon will be having a number of headquarters or offices. All of them need to maintain a unique data. If you are not maintaining a unique data format, if everybody try to dump data at this common database, then data will not be properly arranged or it is inconsistent. That is how data will be having some inconsistency problems. Because of these reasons, we can call data is dirty in nature, and we need to analyze such type of data without any problems. That's the reason we are going to learn about data pre-processing. Okay, so now let's try to understand why is data pre-processing very important. So there is some important saying that no quality data and no quality mining results. So if you're not providing quality data, definitely your data will be having errors and misconceptions. It may lead to some wrong results. That is, there is no quality of mining results if you are not having a quality data. Okay, so quality decisions must be based on the quality data. For example, if you want to analyze a good student in your class, if you want to take some best 5 students in your classroom, so what we will do, we will try to get data of all those people, like how many, what is the academics percentage, what is their attendance, what is their performance metrics, and how are they behavior, what are the behavior of the students. This is how we try to analyze students data. For example, if I collect that data wrong, and if I select some bad student as a good student, then obviously that is a wrong analysis. If you are not having quality metric data, that will lead to some misconceptions and wrong analysis. Okay, so here example is duplicate or missing data may cause incorrect or even misleading statistics. Yeah, definitely if you are having some duplicate values or some missing values, it may lead to some inconsistency problems. That's the reason we need to perform data pre-processing at every point of time. Okay, and next, data warehouses needs consistent integration of quality data. So because data warehouse is a collection of a number of database, we need to have a consistent data whenever you are going to analyze your data. Okay, next, some methods like data extraction, data cleaning, and data transformation comprises the majority of the work of building a data warehouse. So if you want to build a proper data warehouse with a very good amount of data, you need to perform data extraction, data cleaning, data transformation, integration. These all things are part of your data pre-processing. This is the reason data processing is a building block, or it is the main concept of your data mining. Okay, so okay, let's move ahead to the next thing. That is like, what are the metrics which are important for data quality? That is multidimensional measure of data quality. So a well accepted multidimensional view need to be accurate, complete. So while explaining the concept of data quality, I have given these 5 metrics like accuracy, completeness, consistency, timeliness, believability. These are the 5 important attributes which we have discussed in the classroom about data quality. And apart from that, we are having like interpretability, value added things, data. Whenever you are having about data, it should add some value. Suppose if you are collecting some data which is not useful for anybody, so it is of no use. It's of time waste, right? So whichever the data points or values you're collecting, that should add some value to your data. And next, accessibility. These are the important metrics which are essential if you want to make your data a quality data. Like, so you're having some categories like intrinsic, contextual, representational, and accessibility are some of the important uh, metrics which are used to improve the quality of your data. Okay, so these are the categories of different types of formats or uh, parameters which are useful for your creating of your data quality. Okay, yeah. So this will be the important question from unit 1, second part, that is, what are the major tasks in data pre-processing? So as discussed in the first session about the structure or the tree diagram, whatever we have taken in the classroom. So data cleaning, data integration, data transformation, data reduction, and data discretization. These are the important concepts which are called as major tasks in performing your data preprocessing. Okay, let's look at this one by one. Already data cleaning is being covered in the previous classes, right? Okay, so let's see about learn about data cleaning. First, let's see what is the importance of this data cleaning. So data cleaning is one of the three biggest problems in data warehousing. So if you're not performing data cleaning properly, it may lead to a number of problems with respect to data pre-processing. So data cleaning is the number one problem in data warehousing. So as per the survey, this has been concluded that data cleaning is the number one problem in data warehousing. So if you're working with data warehousing, that is ETL, extract, transform, and load based works, then data cleaning is one important thing which everybody need to learn. Next, what are the data cleaning tasks? So that is filling in the missing values, identifying the outliers, and smooth out noisy data. That is, if you're not having proper data or if you're having some noisy data, then definitely we need to work for your data cleaning. Next, we need to work on inconsistent data, and if the data is not consistent, definitely we need to correct those values, and that's how we perform your data cleaning. Next, that is resolving redundancy caused by data integration. So because during data integration, if you are missing any attributes or any values, it may lead to some problems during analysis. So we need to resolve the problem of this uh, redundancy of your data. Okay, so this is the overview of your data cleaning. Now let's talk about your what actually is missing data. So as already covered, data is not always available. Sometimes it may be missing, sometimes it may not be having problems, it may have problems. So these all things need to be identified. Okay, yeah, just a minute. So missing data is something very important in your data pre-processing, because if your data is not properly aligned or not properly available, whenever you are doing some analysis, it may lead to some wrong analysis. So missing data may be due to equipment malfunction. That is, assume that you're working on your Excel. Sometimes you basically it happens with our general life. That is, if you're working with an Excel or Word, and suddenly it will be if you're trying to put on more amount of data, due to the improper working of your system, it may randomly close your Excel due to some heavy data or any problems. So if your system or equipment is not working properly, for example, if you are trying to collect some data through sensor, for example, if I say about traffic sensor, so traffic data sensor want to collect about in which place how many vehicles are being moving every day. That is, it want to just get the count and assume for some time the sensor is not working properly. So that day's data might be a problem in that area. So because at that time, if the sensor is not working properly, it will not collect the data, right? So the data will be missing. So it can be due to some equipment malfunction, or it can be due to some inconsistency in your data with other recorded data and thus deleted. So uh, data not entered due to misunderstanding. So this happens because of the system operators. If they are not aware of such any of the data, they might be skipping that. So that might be some important data which is very useful, but it is because a person sitting in front of the system might not understand about what is that, so it will be removed or it is not taken into consideration. It is something which you need to understand. Next, certain data may not be considered important at time for entry. So assume that if I want to process your results, definitely attendance is not important for me, because results are dependent on the marks what you have scored in the examination, right? So at that time, attendance might not be important for us, but in the next scenarios, whenever we want to correct your attendance, again we need to do a rework. So depending on the importance of that data value, we may correct or might not correct that data points. And missing data may be due to not registering of history or change of the data. So basically, in many systems, we collect some log data. So log data is important to understand who is coming into in and going out at what time. These are some of the things. So if that is not properly available in your data, then in real world it may be a lot of, it may create a lot of problems. And missing data may need to be inferred, that is properly verified and accordingly we need to update that. So missing data will lead to a number of problems. So we need to have a proper understanding of what are these missing data and how to clean this data. Yeah. Next, how to handle missing data. So this is already covered in the previous session. That is ignoring the tuples, filling in the missing values manually, filling in the missing values automatically. Likewise, we need to understand what actually is attribute mean, what is a global constant. These are all things we have seen in the previous session. And one important thing highlighted here, that is the most probable value inference based, such as Bayesian formula or decision trees, are also very important whenever you are having some missing values to identify outliers or all those things. Yeah. So this is also something we have seen previously about what actually is data. So data is a collection of data objects and their attributes. So you can see here what are the objects, what are the attributes, what are the data values, which are very, very important. An attribute is a property or characteristic of an object, and each attribute will have some data values which are called as objects, from which we will be analyzing a number of things. For example, eye color of a person, temperature. Here you can see the ID, refund, marital status, tax, income, etc. So in this data, you can see it is about whether there is some cheating in the tax payment or not. So a collection of attributes will describe an object. So here you can see the attribute has having some values. This is what we call it as data objects. Okay, object is also known as record, point, case, sample, entity, or instance. So it can be called through any of the name. Okay, yeah. So attribute values, as I said, here you can see the ID values under this ID, refund. All these are nothing but your attribute values. So attribute values are numbers or symbols assigned to an attribute. It can be numerical values, characters, letters, or some strings. All these will be considered as attribute values. Okay. Different attributes can be mapped to the same set of values. For example, attribute values for ID and age are integers. So because of the constraint here that integers, they can be mapped into the same set of values. But properties of attribute values can be different. So attributes can be mapped, but their properties will be varying. For example, ID has no limit, but age has a maximum and minimum value. For example, if I talk about employee, an employee's age can be maximum of 60 and minimum of 25. That is how we need to consider some attribute values. But ID, it's again, there is no limit according to number of students in that campus or that college will be having such type of values. Types of attributes, this is also already being covered in the previous class. That is nominal, ordinal, interval, ratio, and ratio scaled and interval scaled, which we have seen. The same examples we have covered in the previous class. You can refer your notes regarding this, what we have covered. Next, or already these are also covered, like properties of attribute values. They should be having some distinctness. They should have some proper order. They should have some appropriate identification, like what you want to do, multiplication or subtraction. These all things we will be talking. And here you can see in nominal attribute, it will be having some distinctness. And if you are taking data with respect to ordinal attribute, it is distinctness and order. And if I talk about interval attribute, it is distinctness, order, and addition. Here you can see the type of attribute depends on which of the following property it possesses. For example, nominal attribute will only talk about this equal to and non-equal to, whether equal or not equal. And ordinal attribute will talk about the order also. For example, ratio attribute will talk about all these four properties. Okay? Yeah. So this is a brief differentiation between each of the attribute, why it is being used, what are the examples, and what are the various operations which we can perform with respect to each attribute. This is again a very, very important slide for our understanding. This particular point we have explained in the class, but this type of separation is not done. So this slide will be very important for you to understand about the different types of attribute values. Okay, here you can see the levels, how data is being transferred, and in detailness of your different types of attributes. There is some mess up here. Okay. Yeah, so this will be a bit clear one, maybe size problem. Okay, now this looks much better. Okay, so like how we'll be trying to work with these different types of values. For example, you can see nominal values are like any permutation of values. If all employee ID numbers were reassigned, would it make any difference? Definitely, employee ID is something very, very important, because depending on employee ID only, they'll be calculating the biometric attendance and all these things, and such they'll be trying to pay the salaries. Okay, yeah. So discrete and continuous attributes, I have given a differences between these two. What are discrete values which are finite? Continuous values are not finite. They will be only having some limitations. Okay.